Thousands of years ago, during the Quaternary period, megafauna roamed the land. These creatures were giant versions of the birds, reptiles, and marsupials we see today, weighing at minimum over 40 kilograms, and for some, much more. These species were widely distributed across the historic continent of Sahul, what is now Australia, Papua New Guinea, and Tasmania. However, by the end of the Upper Pleistocene, these prehistoric megafauna were all gone. So the big question is, what caused megafaunal extinction? The two biggest hypotheses suggest either extreme climate or human arrival as contenders, but there is a significant data gap when trying to situate megafaunal extinction on this timeline. Through their study of fossil deposits in South Walker Creek, Hocknell and his associates have come to a few conclusions. 4 sites along the creek were examined, and fossil flora and fauna identified, with at least 16 megafaunal species found, including the marsupial lion and the diprotodon. These fossils and fossil sediments were analysed using a combination of multiple techniques, including uranium-series dating, radiocarbon dating, electron spin resonance, and optically stimulated luminescence, or OSL. The depositional age was identified using OSL, while the age of organic inclusions in the samples was measured with the other 3 methods. OSL dating provides a measure of the time since the sediments were deposited and last exposed to sunlight, and since the naturally occurring minerals in these sediments are able to record the amount of ionized radiation they were exposed to, this allows us to date them. Additionally, U-series dating was used to date teeth samples in order to determine the uranium concentration in them and discern a minimum possible age for the bone. Finally, the prehistoric hydroclimate was studied through a variety of paleo-environmental proxies that explored the possible trends in climate and vegetation at the time. So what did they find? From the U-series dating, they were able to date the last appearance of megafauna in this area to 40.1 Ka, and within each basin, the youngest dated megafauna occur during or just prior to the onset of abrupt hydroclimatic deterioration. This deterioration involved reduced rainfall and water access, reduced rainforest and grassland, and intense increased fire. Further still, there was no evidence of human kill sites, and the pattern and distribution of human arrival did not appear to mimic that of megafaunal extinction, indicating they were not a direct cause. Therefore, Hocknell and colleagues deduced that megafaunal extinction in South Walker Creek was most likely due to hydroclimate deterioration and sustained environmental changes that were detrimental to the survival of aquatic and terrestrial megafauna of the area, not human hunting.